Hi everyone. In this video, we are going to see a binary search. What is binary search? A binary search is a searching technique used to find an element in a sorted array by repeatedly dividing a search interval into half. Next, purpose of binary search. To quickly find an element in a large data set, to reduce the number of comparison, used in applications like database, searching lists, etc. It's more efficient than linear search. Next, we are going to see how it works. Start with low equal to 0, high equal to n minus 1. Next, find middle index. The formula is mid equal to low plus high divided by 2. I need to compare. If array of mid equal to key, element is found. If array of mid less than or key, search right half. That means low equal to mid plus 1. If array of mid greater than or key, search left half. That means high equal to mid minus 1. Repeat until element is found or low greater than or high element not found. Here are some advantages and disadvantages. Advantage: faster than linear search, time complexity, efficient for large sorted data sets. Disadvantage: works only sorted data, slightly complex to implement, not efficient for linked list, not suitable for small data sets. Next slide, we are going to see binary search using recursion. It is a technique that searches a sorted array by repeatedly dividing it into halves using recursion. Next purpose: to search efficiently in a certain list, to reduce time complexity compared to linear search. Time complexity is O of log n, useful for large data sets, and to implement searching using the divide and conquer method. Next, we are going to see how it works. Find the middle element of the array. Compare the target value with the middle element. If equal, element found. If smaller, search in the left half. If greater, search in the right half. Repeat the process using recursion until element is found or search space becomes empty. Firstly, we can see the program of binary search. The program starts by header file using hash include stdio.h. In the main function, variables are declared. Array are sought to be store array elements. N for the size of the array. X for the element to search. First, last, and mid for position tracking. Flag to check whether the element is found or not. The user is asked to the size of the array of n. The user then enters the array elements in ascending order. This is important for binary search. The user is asked to enter the elements of X to search. The variable first is initialized to starting index. The variable last is initialized to n-1, that is ending of index. The while loop runs as long as first less than or equal to last. Inside a loop, the middle position is calculating using mid equal to first plus last divided by 2. The program checks if the middle element array of index is equal to x, that is, if yes, flags is set to 1 and the loop stops. If the element is greater than the middle element, the search continues in the right half of by setting first equal to mid plus 1. If the element is smaller than the middle element, the search continues in the left half by setting last equal to mid minus 1. After the loop ends, the program checks the flag value. If flag equal to 1, it prints that the element is found and shows its position mid plus 1. Otherwise, it prints that the element is not found. Finally, the program ends by returning of 0. Here are the outputs. Next, here's a program of binary search using recursion. In this program, perform a binary search using recursion to find a given element in a sorted array. First, in the main function, the user enters the number of elements and they input the array values in ascending order. Then the user provides the element key to the searched. The program calls the recursive function binary of search of by pausing the array, starting index of low equal to 0, ending index high equal to n minus 1, and the key. Inside the function act is first checks whether the search range is valid, that is low less than or equal to high. If it is valid, it calculates the middle index of the array. Next, the program compares the key with the middle element. If both are equal, the function returns the position, indicating that the element is found. If the key is smaller than the middle element, the function calls itself recursively to search in the left half of the array. If the key is greater, it recursively searches in the right half. The process continues until the element is found or the search range becomes invalid. If the range becomes invalid, that is low, greater than or high, the function returns minus 1, meaning the element is not present in the array. Finally, the main function checks the returned value. If it is minus 1, it prints that the element is not found. Otherwise, it prints the position of the element. Here is the output. I hope all you understood this video. Thank you.